In this video, our goal is to continue some examples on how to test hypotheses on difference of two independent population means. To motivate that, we consider this example. Do women feel differently from men when it comes to tax rates? One question on a survey of randomly selected adults asked, what percentage of income do you believe individuals should pay in income tax? We're going to look at the data in a little bit in order to complete parts A through C. So the first part A say we should draw a side-by-side box plot of tax rates by gender. Does there appear to be a difference in the income tax rates between genders? Let us see. In order to draw the side-by-side box plots, the first step is to copy your data into StatCrunch. I believe in MyStatLab, you might find out that the data sets are provided in two columns. What I did was to take the last two columns, copy it or cut it, and then paste it right under the first two columns. So I have female and I have male. In order to get this going, I'm going to go to Graph, go to Box Plot right here. Box plot right after stem and leaf. Box plot. Then I would like to indicate that what I'm working on, it will only allow you to pick number variables. So tax rate is what I want. So tax rate, and I would like to divide them or split them by gender. So group by gender. So I'm going to go to gender right there. And I would like to draw the boxes horizontally. Since we read from left to right, that orientation is really nice. And I might like to look at the median, and I believe that should work. So you have compute, and this is it. So I have my side-by-side box plot. What you want to observe immediately is this is the tax rate. We see that it appears that females tend to believe in a little bit more tax rate, and the median is, of course, way higher than that of what the males. This might be suggesting to us that the income tax rate for females appears to have a higher median than that of males. So let's write that down. So based on that, we can set up a hypothesis here, and we'll see how we're going to do that. So based on what we saw in the side-by-side box plots, we can say that yes, there appears to be a difference in income tax rates between genders. And that is because the tax rate for females appears to have a higher median than the income tax rates for males. Just one more time, this is for females. They tend to have a higher tax rate than that of males. All right, then based on that, let's see. Explain why a hypothesis test may be used to test whether the mean tax rate for the two genders differ. The reasons are as follows. 1. Each sample is a simple random sample. 2. Each sample is obtained independently of the other. 3. Each sample size is large. 4. Each sample size is small relative to the size of its population. Question C. We're to test whether the mean rate for females differs from that of males at alpha equals 0.01 level of significance. What you need to do in this case is, first, we're going to define the mean tax rate for males and the mean tax rate for females. So mean tax rate for males, and then this is the mean tax rate for females. And once that is done, we note our alpha equals 0.01 level of significance. I'll write that later. First, let's write the null and the alternative hypothesis. That will be followed by the level of significance. What do we want to test? That the mean is different. Well, that means we should go to the alternative, test that the mean for males is different from the mean for females, versus the mean for males is the same as the mean for females. Then the next thing is, of course, to get, this is step 1 there. Step 2 would be to get the test statistic and the critical value. So let's do that versus the critical value. And in step 3, we will get the p-value in the same process. So how do we do that? We go to StatCrunch. In order to get the test statistic versus the critical value, going back, I am going to copy right from where I have males all the way down. I'm going to copy this, I'm going to cut it away, and I'm going to paste that here. All right, okay. I think that's an error there. I'd like this to be right here. And I'll say male here. Okay, male underscore gender. I'll take that as my title for this case. All right, what is going on? All right, and then for the values, I'll say tax underscore male. Good, just to separate. I am doing this because StatCrunch makes it easier that way. So then go to Stat, go to Test Statistics, go to T Statistics, go to To Sample, and then go to With Data. Then for sample 1, you want to indicate that that is in tax rate. So I'm going to put that in tax rate. And then sample 2, that is for tax male. So I'm going to indicate that, tax for males. All right. And then what do I want to check? I want to ensure that my alternative, the symbol or the inequality in my alternative reflects in the test. And my alpha is 0.01. So let me check. Not equal to, that's important. And then show critical value, 0.01, and compute. So I have the values here. So in this case, it stands to reason that I have my test statistic there. My test statistic is 0.990 and my p-value is 0.3261. So I have my test statistic value there, 0.99. My critical value, drawing my distribution. This is a two-tailed test. So I'm going to draw two tails here. And I have the pieces here. What is my critical value? My critical t value is 2.663. So negative 2.663 on the left, and then positive 2.663 on the right. And I can see that 0.99 falls not in the rejection region. The p-value for this test was also provided, 0.3261. 0.3261. So again, this does not fall in the rejection region. So we are not going to reject the null hypothesis. So do not reject the null hypothesis. And that means, so again, to emphasize, since 0.99 does not fall in the shaded rejection region, rather it falls outside, we do not reject the null hypothesis, which means it stands to reason. That means we do not have enough evidence for the alternative that we want to test. So there is not enough evidence at alpha equals 0.01 level of significance to conclude that the mean income tax rate for male is different from that of females. With that concluded, we proceed to the next example. In this example, we are told that a random sample of 40 adults with no children under the age of 18 years results in a mean daily leisure time of 5.62 hours with a standard deviation of 2.37 hours. A random sample of 40 adults with children under the age of 18 results in a mean daily leisure time of 4.37 hours with a standard deviation of 1.89 hours. Let mu1 represent the mean leisure hours of adults with no children under age of 18, and mu2 represent the mean leisure hours of adults with children under the age of 18. Construct and interpret a 90% confidence interval for the mean difference in leisure time between adults with no children and adults with children. So let's set this up. So what I have prepared here on the screen helps you to unpack the question. For population 1, this will be parents with no children under the age of 18. And the sample size taken there, n, is equal to 40. And from that sample, we gathered an average for that sample, which will lead to a sample mean of 5.62 and a sample standard deviation of 2.37 hours versus n equals another 40 for adults with children under age of 18, sample average or sample mean of 4.37 and sample standard deviation of 1.89. And we want to use this to get a 90% confidence interval for the difference, which is mu1 minus mu2. So we'll take that to StatCrunch, this information. So going to StatCrunch, I'm going to close this, go to Stats, go to T-Stats, indicate that you want to work on 2 sample, and indicate that this is with summary. So it's going to ask you for the sample mean. So in other words, sample mean here is 5.x bar, which is 5.62. So I'm going to type that 5.62. And then sample standard deviation. Oops. Let's go back. Sample standard deviation for the first one. So I have 2.37 and 40. Okay. 2.37 and 40. Then for the next one, I want population 2. I want the sample mean 4.37. 4.37. The sample standard deviation 1.89. And then this was 42. So the sample standard deviation was 1.89 here. All right, with that said, once we key those parts in, we need to indicate that we want to compute a confidence interval and at what level. Let's see, was it 95? 90%, 0.90. So 0.90, and indicate that I would like to show the critical value and compute. And that's it. So I have the lower limit and I have the upper limit. So from this value to this value. So I have those values here, the lower limit and the upper limit of the 90% confidence interval for the differences. So as it stands, that I got from here. All right, the next part will be to interpret this confidence interval. Let's see how that is done. To interpret the 90% confidence interval for the difference, we note that the first case interpretation is that there is a 90% confidence that the difference of the means, mu1 minus mu2, is in the interval or range from 0.45 to 2.05. A very critical note is that this interval does not contain 0 at all. If it contains 0, it means that this difference could potentially be 0. That is, if it contains 0. In this case, the interval does not contain 0, which means that the difference can never be 0. If the difference can never be 0, it means the difference can never be nothing. It can only be something. If the difference can be something, it means there is significant difference in the number of leisure hours that adults with no children and adults with children under age 18 have as leisure hours. So with that done, let's move on to the last question for this chapter. Example, a random sample of n1 equals 31 results in a sample mean of 123.3 and a standard deviation of 8.5. Take note, we'll take this as one sample. Then, an independent sample of size n2 equals 50 results in a sample mean of 129.8 and a sample standard deviation of 7.3. Then, does this constitute sufficient evidence to conclude that the population means differ at the alpha equals 0.10 level of significance? The reality is we are testing hypotheses on population means, and they are independent samples. So in this case, the appropriate type of test to be used is the Welch's approximate t-test. Let's write that down. So the type of test that should be used is a hypothesis test regarding the difference of two independent means using the Welch's approximate t-test. Then a quick follow-up then would be to determine the null and the alternative hypothesis. The null and the alternative hypothesis at alpha equals 0.10 level of significance. So what do we want to test? We want to test if the population means differ. That will simply be mu1 not equal to mu2, which means mean of the first population equals mean of the second population will be the null hypothesis. Then the next step is to use technology to calculate the p-value. So take note, we're going to need the green details and the pink details. So let's see. Let's go back to StatCrunch. I'm going to close this, go to Start, go to T-Stats, to sample with summary. And what summary values do we have? We have the sample size for the first group, 31. So I can put 31 here. And what is the sample mean for that first group? First, that was 123.3. So let's do that, 123.3. And the sample standard deviation for that first group was 8.5. So you have 8.5 here. And then I'm going to do the same for this. Then I'll be back. So here on the screen, you see the sample 2 details, the sample mean, the sample standard deviation, and the sample size, which I got from the pink part of the problem here. The sample size, the sample mean, and the sample standard deviation. And I will note that my alpha, my level of significance is 0.10. And I want to get the p-value for hypothesis test. So let's go back. I definitely want a hypothesis test. I want to check the inequality that it is not equal to. And that is true, not equal to. Then the next step is to ensure that you click on show critical value when the significance level is 0.10. Okay, so let's change that. 0.10. And we would like to compute that. So to compute, we have the p-value here, which is 0.00008. Okay, so let's do that. The p-value is equal to 0.0008. Let me check how many zeros. 3 zeros after the decimal. 0.08. And we're now to draw a conclusion. So it is time to compare the p-value to alpha. We know that if we recall the decision rule, we usually reject the null hypothesis if the p-value is less than alpha. We need to check if that is so in this case. Our p-value is 0.0008. It is definitely lesser than what? Alpha. So we're ready to draw a conclusion based on that rule of decision. So since the p-value of 0.008 is lesser than alpha, which is 0.10, Then, based on the decision rule, we reject the null hypothesis and conclude that there is sufficient evidence to reject the null hypothesis because the p-value is lesser than alpha. That concludes the solution to this problem. All right.